This section is 4.1, which is identifying and graphing sequences. So we're going to start by defining a sequence. So a sequence is just a list of numbers in a specific order or pattern. So a sequence could be something like 2, 4, 6, 8. That is a list of numbers and they have a pattern. A term is each element in the sequence. So those are the actual numbers in the sequence. So the sequence is the whole thing and the term is the actual number. So here we have a table which lists a sequence. So the numbers up here are actually the term numbers, and then this down here is the actual sequence. So the sequence would be 5, 10, 15, 20, 25, but we would say 20 is the fourth term, 10 is the second term. So now we're going to go ahead and move into different types of rules for sequences. So our first one is an explicit rule. And an explicit rule is used to find the nth term in a sequence. So, for example, if I have some rule that's given in an explicit form, if I wanted to find the 100th term, I would just easily plug in 100 for n. So we're going to go ahead and try a couple examples. So it says to write the first 4 terms of the sequence using the explicit rule. So it's explicit because I can just plug in 1 to find the first term, 2 to find the second. So what I'm going to go ahead and do is make a table. So I know that I need to plug in 1, 2, 3, and 4, because to find the first term, I have to plug in 1. So to find the first term, I'm going to do f of 1 equals, and then wherever I see an n, I'm going to plug in 1. So that will be 1 squared minus 1, which is 1 minus 1, which is 0. And then we're going to do that again. F of 2 equals n squared, so 2 squared minus 1, which is 4 minus 1, which is 3. F of 3 equals 3 squared minus 1, which is 9 minus 1, which is 8. And f of 4 is 4 squared minus 1, which is 16 minus 1, which is 15. So to find the first 4 terms in the sequence, our first 4 terms would be 0, 3, 8, and 15. Okay, we're going to go ahead and try another one. This one's a little bit more involved. So I'm going to go ahead and make a table again. So I have n and f of n, and I want to find the first 4 terms. So again, if I want to find the first term, I plug in 1. If I want to find the 4th term, I plug in 4. So I'm going to skip the whole f of 1 because we already know that we need to do that. So we're just going to write 3 times 1 squared plus 2. So this is where you have to follow your order of operation. So we're not going to do 3 times 1 and then square it. We're going to do 1 squared and then times 3. So 1 squared is just 1. So it's really 3 times 1 plus 2. So 3 times 1 is 3, and then 3 plus 2 is 5. And then we keep going. So this would be 3 times 2 squared plus 2, which would be 3 times 2 squared, and 2 squared is 4, plus 2. So this is 12 plus 2, which is 14. 3 times 3 squared plus 2, which is going to be 3 times 9 plus 2, which is going to be 27 plus 2, which is 29. And lastly, 3 times 4 squared plus 2, which is 3 times 16 plus 2, which is 48 plus 2, and you'll get 50. So the first 4 terms in that sequence are 5, 14, 29, and 50. So the next problem is a your turn, which means that you're going to go ahead and try it on your own, and then we will do it together. So for this one, same setup. We have our n and our f of n, and we want to find the first 4 terms. So I just plug in 1. So this one's actually pretty simple. So it's going to be 2 times 1 plus 3, which is really just 2 times 4, which is 8. The next one is 2 times 2 plus 3, which is 2 times 5, which is 10. And hopefully we're kind of seeing a pattern too. 2 times 3 plus 3, which is 2 times 6, which is 12. And lastly, 2 times 4 plus 3, which is 2 times 7, which is 14. So the first 4 terms are 8, 10, 12, and 14. Okay. So these last 3 examples were all using the explicit rule, which allows you to find any nth term. Now the recursive rule, you have to know the previous term in order to find it. So we need to know previous term in order to find the nth term. Okay, so it builds off of the previous answer. As opposed to plugging in n, you actually would plug in the previous answer. So we want to write the first 4 terms of the sequence using the recursive rule. So I will be showing you 2 different ways. I think I know the way that most of you will do it, which is the easier way, which is what I do. But I'll show you kind of like how you would plug it in if you wanted to do it that way. So I'm going to plug in, so I have the first 4 terms. Okay, so we're actually given the first term, which is 2, okay? So if you wanted to do it the plug-in way, I would do f of 2, right? So I can still plug in 2 to find the second term, and I would plug in 2 anywhere I see an n. So it'd be f of 2 minus 1 plus 3. And what this is actually saying is it's f of 1 plus 3. So f of 1 is your first term in the sequence, and our first term in the sequence is just 2. So it ends up being 2 plus 3, which is 5. So we'll try one more like that, and then hopefully we'll see a pattern. So if I wanted to find f of 3, this would be f of 3 minus 1 plus 3. And that turns into f of 2 plus 3. So f of 2 is the second term in the sequence, which is 5, and 5 plus 3 is 8. So then from there, you can kind of see a pattern. We're just adding 3 each time. So the next term would be 11. The other thing is this piece right here, f of n minus 1, it just means your previous answer. So you're going to take your previous answer and you're going to add 3. So let's go ahead and use that method. And again, I'll write out my terms. I'm going to go ahead and use that method for this next example. So I will write out our table. So we have the first term is 4, but we need to find the second, third, and fourth. Now, when you look at this, it's really 2 times the previous answer plus 1. So think of it like if I'm finding the second term, it's 2 times the previous answer plus 1. Okay, so the previous answer in this case is 4. So 2 times 4 is 8, and 8 plus 1 is 9. We're going to do that again. 2 times the previous answer plus 1. Well, the previous answer this time is 9. So now it's 18 plus 1, which is 19. And lastly, 2 times the previous answer plus 1. The previous answer is 19. So this would be 38 plus 1, which is 39. So the first 4 terms are 4, 9, 19, and 39. So again, you can absolutely plug in and do the whole f of 1, but personally, I think the second way that we did it is much easier. Okay, the last topic is graphing sequences. So we have Tanisha has $10 in her piggy bank in week 1, and she adds $5 for the next 5 weeks. So the first thing that we should do is set up a table with this information. So in week 1, she has $10, and then she does it for 5 more weeks. So that would be second, third, fourth, 5th, and 6th. So that's 5 more weeks. So each week she's just adding $5. So I'm going to go ahead and do that. And we want to graph this sequence. So I'm going to go by 5s, 20, 15, 10, 5. Okay, so the x-axis is going to represent the week number, and I'm just going to go by 1s. So this is your week. And then the y-axis is going to represent the dollar amount. Okay, so the amount of money saved. And we're going to go ahead and plot those. So for week 1, $10, and week 2, 15, 3, 20, 4, 25, 530, and 635. So the big question is, do we connect these? Well, because this is a sequence, we are not going to connect them. So yes, we could, perhaps put in different amounts of money throughout the week, but it doesn't say that. So the whole point of why we're doing this is we want you to know that sequences are always discrete. So think about if we're having a pattern, I wouldn't say the 5.5 term is 12, for example. So for sequences, whenever you graph them, you want to leave them as unconnected dots.